Right, hello everyone. We will be starting with the session now. Good afternoon to all. Dear authors and invited guests, welcome to Technical Session 8A. I am Dhimahi Patel and the moderator of the session. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology. Sorry for the network interruption just before. Let me continue. In this session, we have 10 presentations. Each presenter will be given 10 minutes for presentation and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to us in the chat box. Now, before we proceed, I would like to introduce you all to the chair of the session. We have with us Dr. Ganesh Pise. Dr. Ganesh is an assistant professor at Vishwakarma Institute of Information Technology, Pune. With over 15 years of experience in academia and research, his areas of expertise include artificial intelligence, machine learning, and Internet of Things. He continues to contribute to academic excellence and technological advancement through teaching, research, and innovation. A warm welcome to you, sir, and I invite you to kindly share a few words with us.
Thank you, madam. Am I audible?
Yes, sir.
Yeah. So thank you for inviting me as a session chair. I hope all the participants will follow the instruction given by the chair committee. So I request you to continue the session.
Yes, sir. Thank you very much.
Okay.
Now we will be proceeding with the presentations now. First up, I would like to call Rahul Modak to present his study on a comprehensive review of machine learning and deep learning approaches for botnet detection in IoT environments.
Hello.
Hello,
Am I
sir.
audible? Yeah.
Yes, sir.
Let me share my screen. Is it visible?
Yes, sir. We can see your presentation. Please continue.
Thank you so much. Respected session chair, honorable keynote speakers, distinguished delegates, and fellow researchers. Very good afternoon. My name is Rahul Modak. Currently, I am pursuing PhD at MATLAB. It is my honor to present at 10th International Conference on Information and Communication Technology for Competitive Strategies. My research paper is a comprehensive review of machine learning and deep learning approaches for botnet detection IoT environments. This is the index, the structure. I will begin with the introduction to IoT security challenges, followed by IoT device weakness, and machine learning approaches, deep learning approaches, and so on. So start with introduction. The Internet of Things has transformed modern computing by enabling billions of interconnected smart devices across the domain, such as smart homes, healthcare, industry, transportation, and smart cities, etc. From recent studies, that the number of IoT devices is expected to exceed 50 billion by 2025. However, the critical concern is that nearly 90% of these devices are unmanaged, meaning they operate without continuous monitoring, security updates, or user intervention. This unmanaged nature of IoT are highly attractive to attackers or hackers, leading the emergence of IoT botnets, such as Mirai attack, which have caused a serious and the largest DDoS attack in history. So, traditional rule-based intrusion detection systems are no longer sufficient from this type of attacks. Hence, the machine learning and deep learning-based approaches come into the play. Next, IoT devices weakness. So, the main weakness of IoT devices is we are never change or rarely change the main password, like admin or admin. And there are many open code like CANnet, SHA, etc. Also, there is limited firmware updates, or mainly some of the devices have no firmware updates and are outdated and vulnerable software. Furthermore, IoT devices have limited computational power, memory, energy, make it difficult to deploy the traditional security solutions. Next, what is botnet? A botnet is a network of compromised devices, also known as bots or zombies, that are remotely controlled by an attacker. Attacker communicates with these devices through command and control servers, often using encrypted channels. IoT botnets are commonly used for distributed denial of service attacks, spam generation, phishing attacks, etc. What makes the IoT botnets are particularly dangerous is their scale, heterogeneity, and stealthy communication behavior, which is allow them evade conventional detection system. Next, IoT botnet architecture. There is mainly three types of botnet architecture. One is centralized, which use command and conquer server via IRC and HTTP. It is a simple, although efficient, but if the server is down, then the total botnet is failure, which is single point of failure, and it is easier to detect, like Mirai and Tsunami. Second is decentralized botnet. Here is no server needed for this because it's a decentralized structure, which is highly resilient and harder to detect, but it's difficult to manage, like Hajime and Mosaic. Uh, Next is hybrid, which is mixed centralized and decentralized structure. It is highly complex and highly resource intensive, like Configure and World. Next is machine learning approach. We reviewed many papers starting with the machine learning approaches. Mainly, the machine learning approaches have been widely adopted for IoT botnet detection due to their relatively low computational cost. Commonly used algorithms, including random forest, support vector machine, naive-based decision tree, and KNN. These approaches rely on statistical and flow-based features, such as packet length, arrival time, protocol time, and connection duration. While the machine learning models provide a good performance, but they heavily depend on manual feature engineering, which is prone to error, often struggle to detect zero-day or evolving botnet attacks. Next is deep learning approaches. Deep learning approaches address the limitation of traditional machine learning models by automatically feature learning from raw data. Models such as CNN are effective in capturing spatial patterns, while the LSTM and BiLSTM networks model are capturing temporal dependency in raw traffic flow. Autoencoder are often used for unsupervised and anomaly detection, especially when the label data is limited. Studies continuously show that the deep learning models achieve higher detection accuracy and better generalization, particularly for complex complex botnets like Mini, etc. However, the models are computationally intensive and may not suitable for deployed directly on IoT devices. Next is hybrid approaches. The hybrid approaches combine multiple techniques to leverage their respective strengths. A common example of this is CNN LSTM architecture, where CNN layer extract the spatial features and LSTM layers are captured temporal behavior. Some studies integrated feature selection algorithms such as genetic algorithm to reduce dimensionality and improve efficiency. Hybrid models generally outperform the standalone approaches but introduce higher complexity and traditional overhead. Next is ensemble models. Ensemble learning improve detection robustness by combining multiple models prediction from multiple classifiers. These techniques such as bagging, boosting, stacking, and memory voting are frequently used. Ensemble models are particularly effective in handling imbalanced dataset and reducing false positive rates. However, deployment require careful design balance between balance, accuracy, and latency. Optimization algorithms are increasingly used enhanced model performance, such as meta-heuristic techniques such as genetic algorithm, particle sum optimization, and blood eagle search optimization are employed in feature selection and hyperparameter tuning. These approaches significantly improve accuracy and conversion speed. But this introduces additional computation cost, which is making real-time deployment more challenging. Next is dataset. Several benchmark dataset are commonly used in IoT botnet, such as Envelop IoT, Bot IoT, CIC IoT 2017, 2018, UNSW, NV15, etc. But uh, while this dataset enabling the comparative evolution, many suffer from class invariance, synthetic traffic patterns, and limited attack diversity. This highlights the need more realistic and continuously update datasets. Next is challenges. Based on the review, several key challenges are identified. Most of the proposed models perform well in control environment evolution, but lack in validation in real life environments. Issues such as concept drift, model explainability, scalability, and privacy preservation are often overlooked. Also, there are significant gap and high research accuracy and practical deployment feasibility in real IoT networks. Next is future direction. To the summary, that the future research should focus on developing a lightweight, adaptive, explainable intrusion detection system for IoT networks, because we all know that IoT systems are resource constraint settings. Federated learning and age-based detection can address privacy and scalability concerns. Additionally, integrated online learning, cross-data validation, and automated mitigation mechanism will also significantly enhance the IoT security. On the future IoT detection systems should go beyond the identification and integrate self-healing mechanism, automatic quarantine, traffic routing, patch development, or in configuring upon detecting an attack to reduce downtime. Last is conclusion. Conclude that IoT botnet represent a rapidly evolving and serious cybersecurity threats. Machine learning and deep learning techniques have demonstrated strong potential for botnet detection, but most of the solutions not yet ready to deployment ready. Bridging the gap between accuracy, efficiency, explainability, and real-world applicability remains a critical research challenge. Thank you so much. Now I am ending my presentation. Thank you so much for your time. Thank you.
Ganesh sir, any questions for him?
Yes. Very nice presentation, and within a time you have concluded. Thank you for that. I
Thank
have
you so
one
much, sir.
doubt.
Yeah,
For
sir. Please.
whatever the data set you have used,
No, sir.
what is the size of data set which you have used in your research?
Oh, no, sir. It is a review paper. Multiple authors have used multiple dataset like Envelop IoT, Bot IoT, CIC IoT 2017 or 18. Most of them use as a binary classification, not multi-classification. Although it is suffering from most of them suffering from the dataset imbalance, class imbalance, because
Okay.
benign factor is very high than the other attack vector dataset. Yeah,
Okay. As you mentioned that this is the review paper.
yeah.
Just can you tell me what is your thought process on this? What are the main
So,
difference between the traditional machine learning model and deep learning model in terms of the accuracy? Whatever the
in terms
review
of the
you have done.
Yeah, so in terms of accuracy, if we closely uh, thought that main thought process is that the accuracy is like 99% or 98% as author mentioned. But when the heavy traffic load we use or heavy data set we use, then deep learning outperform that traditional machine learning models, because we have to enable the feature selection carefully. The features we have to select the features which is depending upon the model accuracy. But in deep learning case, the model is automatically select that features, a kind of black box model. So we have to use that explainable AI like SHAP or Lime, so we can understand that which features is responsible for the model accuracy.
Okay, fine. You mentioned that the ensemble machine learning. and
Yes, sir. Yes,
bagging,
sir.
boosting, so many
Yeah.
terminology you have presented during
Yes,
your
sir.
presentation. What is the difference between bagging and boosting?
Boosting basically the bagging is that the stacking all the models one by one, and the best accuracy we take. But in boosting methodology is function of the weights. So we take that weights and models, and then we found out that which is model is
Okay,
best.
okay, fine, fine,
Hmm.
fine. Okay,
Thank you so much, sir. Thank
that's
you so
it from
much.
my end. Okay.
Thank you so much.
Thank you so much, sir.
Hmm.
So next, I would like to call Shrikant Kompalwar to present his study on barriers and benefits of patient engagement, a study on digital tools, communication, and health outcomes.
Good afternoon, everyone. My name is Srikant Kompalwar. Today, I will be presenting our study on benefits and barrier of patient engagement in healthcare with the focus on digital tool provider, communication, and hospital environment. So, let's start our presentation. First, with the abstract. The patient engagement is a key determinant of patient-centered healthcare. This study examined benefit and barrier of patient engagement, highlighting that provider communication and hospital environment have strong impact on satisfaction than a digital tool alone. And next slide is the introduction. A patient engagement refer to active involvement of patient in healthcare decision. It supported through a shared decision making, communication, and emotional support and digital technology. But technology is alone is not sufficient. The research highlight that the significant role provider, patient communication, and hospital environment organizer culture in shaping patient experience. The next slide is review of literature. The literature showed that while digital tool improve access, provide patient communication, and support healthcare environment are the strongest predictor of satisfaction and engagement. The high level patient engagement are positively associated with improved treatment and adherence, better healthcare outcome, and enhanced emotional well being, particularly in chronic disease management and surgical recovery context. So, next slide is the methodology. The quantitative study included 130 patients using convenience sampling data. Data was collected via Likert scale questionnaire and analyzed using SPSS, man UTD U test, and Sperman's correlation. The next slide is objective. The objective were evaluate digital tool provider and communication hospital environment, patient engagement and outcome and barrier to engagement to identify the main barriers that prevent patient from actively engaging in healthcare decision. The next slide is our hypothesis. Hypothesis 1, 2, and 3 were accepted, confirming that communication, engagement, and barrier significantly influence the patient satisfaction and outcome. The next slide is our provider communication and environment. This is the strong positive correlation were found between hospital environment and communication clarity, empathy, and patient satisfaction. The next layer is correlation between engagement and health outcome, adherence, and emotional support. Higher patient engagement shows strong association with better adherence and improved healthcare outcomes and emotional support. The next slide is our descriptive statistics on perceived barriers to patient engagement in a healthcare decision making. A major barrier identified were time, constant financial issue, lack of education, and insufficient personalized care. Our next slide is findings. Digital tools alone did not significantly improve satisfaction, communication, and environment were key contribution. Higher level of patient engagement were strongly associated with improved adherence to treatment plans and indicating that engaged patients are more likely follow medical advice and prescribed therapies. The next slide is conclusion. Conclusion is include the patient engagement is a multi-dimensional human interaction and supportive environment are essential alongside digital tools. Thank you, ma'am.
Ganesh sir, any questions for him?
Yes, ma'am. Yes, ma'am. Can you tell me which methodology you have used for this research?
I use the Likert skill methodology.
Can you elaborate it, how it is? How it works? Can you tell me?
Yes, this is a study of quantitative research designed to examine benefit and barriers of patient engagement in healthcare. The statistical test applied for it, UTNU test used to analyze the impact of digital patient engagement tools on patient satisfaction. Second is Berman's rank correlation test was used to examine the relationship between the provider communication and hospital environment, patient engagement, and health outcomes.
What are the biggest challenges in this? Whatever the paper you have written, your abstract in front of me,
Hmm.
what is the biggest challenge you observe in this
The
paper?
limited sample size, and there's convenience sampling bias, since convenience sampling was used to sample may not fully represent all patient groups, affecting external validity. The cross-sectional design, the study captured data at a single point in the time, so it cannot establish cause, effect, and relationship, only
Okay,
association.
okay, okay. Fine, fine. Okay, fine. That's it from my end. Next paper.
Yes, thank you, sir, for your presentation. Now, next, I would like to call Archana Nanade to present her study on bridging the divide, a comparative study of quantum and classical machine learning for loan prediction. Archana, ma'am, or any of the co-authors present with us? Jahida Khan. Jahida, ma'am, are you present? Or the co-authors of this paper? Piali Devnath. Piali, ma'am, please present your study on fog-based intrusion detection systems, a systematic review of machine learning, deep learning, and hybrid IDS architectures and methodologies.
Yes, ma'am. Thank you, ma'am. I'm presenting. Hello, ma'am. Am I audible?
Yes, ma'am.
Good afternoon, respected senior chair, honorable keynote speaker, and fellow researcher. I am Piali Devnath. I am honored to present at 10th International Conference on Information and Communication Technology for Competitive Strategies ICTS 2025 held in Jaipur, India. Today, I am presenting our review paper titled Fog-Based Intuition Detection System, a systematic review on machine learning, deep learning, and hybrid IDS architecture and methodologies. This work focuses on securing IoT environment by intelligent intuition detection at the fog computing layer. Here is the outline of my presentation. I will begin with a brief introduction followed by a discussion on machine learning, deep learning, and hybrid learning approaches used in fog-based ideas. Then I will commonly cover dataset, key observation from the literature survey, future research, and finally conclude the presentation. Introduction. The rapid growth of IoT devices has led to massive data generation at the network edge. Traditional cloud-centric security solutions suffer from the high latency, increased bandwidth consumption, and privacy concerns. Fog computing addresses these issues by bringing computation closer to the devices. However, fog nodes are distributed, resource constant, and often poorly secured, making them attractive targets by cyber attacks. Therefore, there is a strong need for fog-based intuition detection system or FIDS that can detect attacks quickly while operating efficiently within limited resources. Now, fog computing architecture. This slide illustrates the layer architecture of fog computing, which form the foundation of fog-based intuition detection system. At the bottom layer, we have the IoT device layer. This includes a sensor, actuator, smart cameras, wearable, and the other IoT devices. This device continuously generates data but have very limited computation, storage, and security capabilities, making them vulnerable to attacks. The middle layer is the fog layer, which consists of the fog nodes such as gateways, router, access point, and edge servers. This layer acts as the intermediate processing layer between the IoT devices and the cloud. Fog nodes perform real-time data processing, traffic monitoring, and intrusion detection close to the data source. And the top layer is the cloud layer, which provides a high computational power and long-term storage. The cloud is mainly responsible for model training, global threat analysis, policy management, and system updates. Next, the fog security challenges. One of the primary security challenges is fog computing is that fog nodes are often deployed in insecure or unattended locations, such as roadside units, smart buildings, or industrial sites. This makes them vulnerable to physical tampering or unauthorized access. Secondly, fog environment consists of heterogeneous hardware, including gateways, routers, microservers, and embedded devices. This diversity makes it difficult to deploy uniform security mechanisms across all nodes. Another major concern is the large attack surface included by distributing nature of fog computing. Each fog node communication link and IoT device become a potential entry point due to the attackers. Due to this factor, traditional intrusion detection systems are often ineffective in fog environments. They are designed for centralized, stable networks and fail to handle the dynamic resource constant and distributed nature of fog computing. This limitation highlights the need of adaptive, lightweight, and intelligent fog-based intrusion detection system. Next, the need for FIDS. The first and major important need of FIDS is real-time threat detection near IoT devices. By placing IDS at the fog layer, attacks can be identified and mitigated immediately before they propagate through the network. Secondly, FIDS help reduce dependency on the cloud. Instead of sending all traffic to centralized cloud servers, security decisions can be made locally or at all fog nodes, which also improve privacy and reliability. Another key requirement is improved latency, especially for critical domains such as healthcare, smart transportation, and industrial IoT. Low latency detection at the fog layer ensures timely response where delays can be life-threatening or economically costly. Then the machine learning approaches. ML model enhance FIDS by mitigating the unique challenges like class imbalance, feature engineering, and selection. Author 7 tested decision tree neighbors with KNN with the dataset KDD Cup 99 found that DT is better than ND with the percentage of 95% and the KNN is 98% while keeping the runtime with reasonable times. Next, 8 author tested random forest with decision tree and KNN on the dataset DS2OS IoT, applying one hot encoding and feature selection method for received the percentage with random forest with a 99.99%. Even though this performance was strong, the authors did not evaluate cross dataset, which raised concern about the ability to apply this model to the other IoT traffics. However, they do computational overhead. The feature engineering process is still typically done manually. Other research argued that ML is not scalable. Real-time gradients exist. This problem so that we need a better solution, especially for FIDS that are always changing. Next, deep learning approaches. Deep learning models widely used in FIDS due to their ability to automatically learn features and capture complicated fog patterns. Author 9 presented an evolutionary CNN with the accuracy of 99.96% with the dataset of AWID, and 10 author used CNN with the sliding windows to evaluate NSL KDD with the dataset of accuracy 99.46%. Author 11 access 6 DL model with 5 datasets like UNSW, NB15, NSL KDD, etc. with the accuracy of 99% with the LSTM performance of 4. Next, the hybrid learning. Hybrid learning achieves a balance of accuracy, time to classify, and resource consumption by combining best feature of multiple methods. The advantage of different methodologies. Author 12 proposed a decentralized backdrop of IoT smart cities framework that utilize like BiLSTM, CNLSTM, with the achieving of 99.65% with NSL KDD dataset. 13 authored propose and access energy efficient CNN LSTM hybrid method with the percentage of 99.94%, and author 14 proposed and evaluated a hybrid LSTM GRU method with the percentage of 98.68%, but limited by the equality of the dataset. Next, the dataset. KDD CUP 99, an old but popular dataset for IDA research. However, it is outdated, does not represent modern fog or IoT attacks. Next, DS2OS. It's a focus on service misuse and abnormal traffic in IoT system, but it is small and mainly tested in limited environment. And next, CIC-IDS 2017 contains realistic and modern attack types, but some attack classes have few samples which affects deep learning performance. Next, the CIC IoT 2023, a recent and realistic dataset with a diverse attack, but training models on it requires high computational resource and so on. Next, we got some observation from the literature survey. First is model used. Traditional machine learning model is simple but cannot detect complex pattern, but DL handles complex pattern better, and hybrid models improve detection but need some resources. Next, dataset. Dataset more dataset is like NSL KDD CIC IDS 2017. Most are use popular dataset, but many are outdated, do not fully represent real world IoT and fog environments. Next is feature selection. Techniques reduce data size, but may improve important information and increase computation for large datasets. Next is real-time evolution. Real-time detection reduce delay, but increase network load and testing complexity. Next is scalability and adaptability. Online and transfer learning help handle to new attacks, but many models fail on unseen attacks type. Next is our future scope for FIDS. Real-time energy efficient detection. Develop a lightweight FIDS that can detect attacks quickly while consuming very little power. And also federated learning and blockchain integration. Enable privacy preserving collaborative training and secure information for sharing among fog nodes. Next, explainable and human-centric ideas. Make intuition detection and decision understandable and trustworthy for human operators. And so on. Next, to conclude, fog and computing enhance IoT performance and security, but also expand the attack surface. AI-driven fog-based intuition detection system using like machine learning, deep learning, and hybrid approaches so promising result. However, gaps remain in adaptability, explainability, and resource efficiency. Future solution must be lightweight, privacy-aware, and resilient to evolving cyber threat. This is our key reference which we are using in our systematic review. I sincerely thank the ICTCS 2025 for organizing the committee, the session, sir, and audience. Thank you for your valuable time and attention.
Can you go to the conclusion slide?
Yes, sir.
Just go to the conclusions slide. Conclusion slide. Just open it. Okay. In this fog-based intrusion detection system, you mentioned that these three algorithm or technique, machine learning, deep learning, and hybrid,
Yes, sir.
you says that they are performing better. Which one is the most promising you find during your research?
Thank you for your question, sir. The hybrid models are far better from the ML and real models.
Okay. Can you elaborate how this hybrid is? Is there any combination or something else? Why we are going to say the hybrid?
Because sir, in hybrid methods, they are using mixed methods, combining the best features for multiple methods. The advantage like by LSTM and CNLSTM, the mixing methods for CNN is the for feature selection, and the by LSTM is for temporary dependency. This is the best combination for hybrid method, and this is all of it.
what do you think about the most important future research direction of this fog based intrusion detection system? Because already you have gone through the many recent published articles, and based upon that you have done very nice literature survey and the gap analysis. Just I want to know what are the important future research direction for this fog based intrusion detection system.
Yes, sir. The future of FIDS is the must be lightweight, privacy aware, resilient to evolving new threats.
One more question, and that will be the last one. Okay. Why the cloud security insufficient for the fog-based intrusion detection system in IoT?
For heterogeneous data, sir.
Okay. Okay. That's it from my end.
Thank you, sir.
Thank you, ma'am.
Thank you, ma'am.
So next, I would call M. Bhuvaneshwari to present her study on innovations in prime harmonious labeling and their relevance to communication networks.
Yes, ma'am. Ma'am, can I audible?
Yes, ma'am. Please share your screen.
Screen also shared, ma'am. Not visible, ma'am.
No, ma'am. Yes, ma'am. Your PPT is visible now.
Okay. Good afternoon to everyone. I am Bhuvaneshwari from Satyabama Institute of Science and Technology, Chennai. Today I present my paper titled Innovation in Prime Harmonious Labeling and Their Relevance to Communication Networks. This work connects graph theory with the real-world communication networks. Next, coming to abstract.
Bhuvaneshwari, can you keep your PPT on presentation mode? So it will be the visible properly.
Yes. Okay, sir.
Thank you.
Okay, sir. Next, coming to abstract. A prime harmonious labeling is a prime harmonious labeling of a graph. Gamma with the P nodes and the Q lines is a way of assigning distinct number from a set 1, 2, 3, up to etc. to Q minus 1 to the vertices of graph. For every edge that connect two vertices, we define a corresponding edge value in two steps. First, the two end vertices assigned numbers must be relatively prime. Meaning the greatest common divisor is 1. Second one, the value of the edge is obtained by adding the number of its two end vertices and then reducing the result model Q. If these conditions are satisfied for all lines, then the labeling is called prime harmonious labeling. Throughout this paper, we consider prime harmonious labeling as pH labeling and prime harmonious graph as pH graph. This paper explores bull graph, Helm graph, Lobster graph, double comb graph, corona product graph, subdivision of star graph, H graph, and caterpillar graph. Next, we explore applications of communications networks in there are communications networks. Next one, introductions. Graph theory is a field of mathematics that focus on complex connections among nodes and lines. Its swift growth is attributes to its wide-ranging applications in many fields: social science, computer science, biology, and transportation networks. Graph labeling is an applications-oriented area of research in mathematics. Among the various graph labeling techniques such as harmonious labeling, graceful labeling, mean labeling, prime labeling, and so on, this paper explores prime harmonious labeling in various graphs. These labeling techniques are not only theoretical significant but also useful in real-world applications, particularly in computer networks and communication systems. In this paper, focus on identifying graph families that admits pH labeling. In addition, we demonstrated the applications of pH labeling in communications networks, including channel assignment, frequency allocations, secure communications, routing and data integrity. Next one, the methodologies, theoretical analysis of graphs. We considered specific classes of graphs such as bull graphs, Helm graphs, Lobster graphs, double comb graph, and so on. For each graph, we defined a one-to-one vertex labeling function. Using the pH labeling, edge labels are induced and verified to the distinct natural numbers. Applications to communication networks. pH labeling is useful in communication networks for efficient channel assignment and frequency allocations, ensuring minimal interference between adjacent nodes. These uses of co-prime labels improves secure communications and routing and data integrity, and so on. Next one, prime harmonious labeling. These are definitions of prime harmonious labeling. Prime harmonious labeling of a graph gamma with p vertices and q edges is a labeling in which distinct integers from the set of vertices are assigned to the vertex of the graph. For each edge joining two vertices, the label of end vertices must be relatively prime. That is, their greatest common divisor is 1. The label of edge is obtained by adding the label of its end vertices and reducing the sum modulus q. If all edges of graph satisfied these conditions, the label is called prime harmonious labeling, and such a graph is called prime harmonious graph. Next one, graph considered in this work. We prove that the following graphs admits pH labeling: H graph, bull graph, Helm graph, Lobster graph, double comb graph, corona product graph, subdivision of star graph, and caterpillar graph. One more result on this graph. The H graph is a pH graph when n is odd. First of all, you take a graph name gamma Hn graph. First, you put vertices and edges. N is a node of gamma equal to xt, yt. T varies from 1 to n. Next, you put lines or edges. Yt plus 1. T lies between 1 to n. Next, xt plus 1. T lies between 1 to n. Next, xn plus 1 by 2, yn plus 1 by 2. So the vertices are 2n nodes and edges are 2n minus 1. Next, you put assign the labeling of each vertex. Psi of yt equal to t lies between 1 to n. Psi of xt equal to n plus t lies between 1 to n. So according to this process, the line labels becomes 0, 1, 2 up to etc. to q is a bijections. Finding revealed that the line labels and nodes labels are distinct. Therefore, Hn graph is a pH graph, and when n is odd only, not satisfied even condition. These are examples. So first one xt, next vertices are yt. So 1, 2, 3, 4, 5. So these are t varies from 1 to n. 6, 7, 8, 9, t varies from n plus 1. So n is 5. So 5 plus 1, 6. 5 plus 2, 7, and so on. Next, edge labels. Edge labels, sum of the two vertices module total number of edges. So total number of edges are 8. So 8 is zeros. So 1 plus 2 equal to 3. So put assigning the labels 3. Next, 2 plus 3 equal to 5. So put assign the label 5. 3 plus 4 is 7. Assign the label 7. 4 plus 5 is 9. So these labels 9 means 0. So 10, 1, level 2, and so on. So some models Q. So next, applications in communications networks. pH labeling has important applications in communication networks. Channel assignment and frequency allocations, secure communications and routing. First one, channel assignment and frequency allocations. Frequency allocation without interference is a major challenge in wireless communication networks. Prime harmonious labeling assign distinct and co-prime integers labels to nearby transmitters, ensuring mathematical independence between nodes. Edge labels obtained using modular sums represent unique frequency channels for communication links. This avoids channel overlap, reduces interference, and prevents signal collisions. So pH labeling supports efficient spectral utilizations in 5G, IoT, and WSN and so on. These diagrams are first one is 5G networks, second IoT, and third one is WSN. And so next one, secure communications and key distributions. Secure communications requires unique encryption keys for each link between network nodes. Prime harmonies labeling assigns co-prime label to vertices, and each edge key is generated using a modular sum of its end labels. This guarantees unique keys, preventing duplications and unauthorized access. The co-prime conditions also act as an authorizations check, blocking malicious nodes. This lightweight security approach is well suited for IoT, wireless body area networks, and ad hoc networks. Next one, routing and data integrity. Network routing ensures that data packets travel efficiently and securely from the source to destination. Prime harmonies labeling assigns unique labels to communication likes in the networks. Each edge labels is obtained using a distinct modular sum of its end vertices. This generates that no two routing spots share the same identifiers. As a result, routing ambiguities and packets collisions are avoiding. The use of co-prime vertex labels enhance network security. Any malicious or unauthorized node fails the co-prime verification. Such a packets are identified as a corrupt and rejected by the systems. So these are users in 5G edges, MANNet, and so on. So next conclusions, prime harmonies labeling is a systematic methods of assigning values to graph vertices and edges based on relative prime and modular arithmetic principles. In this work, pH labeling is presented for some typical graph families such as bull graph, Kelm graph, Lobster graph, and so on, and its application in communication networks for channel assignment to frequency allocation, secure communications, and routing on exploits. In this future, pH labeling can be generated into more involved graph classes with the help of effective algorithms and used for real-world applications in area like wireless networks, IoT, cryptography, and so on. These are my references. Thank you.
Can you go to the slide number 6, where you have listed the different types of the graph? Graph list is there.
Yes.
So just tell me which graph amongst those studied is most suitable for the pH labeling applications.
Which graph?
Yeah.
Loopster graph. Loopster graph also one of the tree graphs. These are also applications in communications networks.
Okay. And then next question is that whatever in conclusion you mentioned about the pH in the future work,
Yes.
how can the pH labeling be applied in the real life communication network?
Future extension complex graph algorithms and application in IoT and cryptography.
Okay. That's it from my end.
Thank you, sir. Thank you so much.
Thank you, ma'am, for your presentation.
Thank you.
Jahida Khan, ma'am, please present your study on exploring machine learning applications for demand forecasting and performance enhancement in dairy supply chains.
Hello. Yes,
Hello,
ma'am.
ma'am.
Yes, ma'am. I want to share my presentation.
Yes, ma'am.
Is the slide visible, ma'am?
Yes, ma'am, we can see your PPT. Please start with the presentation. Thank you.
Just a minute. I'm not able to see my screen. Just a minute, ma'am. Ma'am, is the screen visible? Because it's not visible to me.
Madam, your screen is visible to us. Just keep it on presentation mode and start.
Okay. Just good afternoon, sir. Ma'am, I'm sorry, but the screen is not visible to me, so I am not able to trace that thing. Just give me 1 sec, ma'am. I'll just
Yes,
stop sharing
ma'am.
and share again.
Yes, ma'am.
Okay. Good afternoon, sir. Good afternoon, everyone. My topic for the presentation is exploring machine learning applications for demand forecasting and performance at dairy supply chains.
Ma'am,
My
can you please make the PPT into the presentation mode?
Yes, ma'am. Yes. Okay. So myself, Zahida Niaz Khan. I am a professor in engineering college as well as a research scholar who is pursuing her PhD from VTU Belgavi, that is Karnataka, India. My agenda and the contents of my presentation will be introduction, supply chain performance of dairy supply chain performance measurement system frameworks, supply chain performance measurement models, key performance indicators of supply chain performance measurement systems, financial performance indicators of supply chain, sustainability performance and measurement of supply chain, demand forecasting of supply chain, demand forecasting using machine learning, what are the proposed innovations in dairy supply chain forecasting, challenges and innovative solutions across dairy sales, stage-wise application of machine learning in supply chains, and the conclusion. To introduce you to my topic, my area is in the dairy supply chain area. So basically, a supply chain is an integrated system wherein the suppliers, manufacturers, logistics, distributors, retailers, customers, all of these work together to address the various issues of the material flow and information flow across the supply chain. Talking in terms of the dairy supply chain, it is a supply chain which it encompasses or it has a very complex network of processes. Even it involves the stakeholders, and there are different activities which are involved in bringing the dairy products right from the dairy farmers to the customers. This process begins with the milk production on the dairy farms, where the cows are raised and milked, and from there the raw milk is collected and transported to the processing facilities. And then these processed dairy products are distributed to the retailers, food service establishments, and other end users through a network of wholesalers and distributors. The dairy supply chain also involves numerous supporting industries, which include suppliers, veterinary services, equipment manufacturers, as well as logistic providers. Now, with time, as the consumer preferences are changing, and there is also an importance to the sustainability part, the dairy industry is facing many ongoing challenges because in optimizing its supply chain and also to take efforts to balance efficiency, product quality, and environmental impact. The reason for selecting this dairy industry as a research area was to just a small statistics. India is the world's largest producing country with 22% of the global production share, followed by the US, China, Pakistan, and Brazil. Apart from this, it is also one of the largest consumer of milk in the world to feed its growing population. So if you see this particular uh, graph, we could understand that the value of Indian dairy market is was US dollars 135.30 billions into 2024, and it is expected to grow tremendously. So it is one of the Indian dairy sector is one of the dynamic sectors in the Indian industry because it shows a very prominent growth in its production and consumption in the last 15 years. And because of the vast volume of processes across the Indian dairy supply chain, it remains as one of the prominent area of research. Now, I've tried to explore the various research areas of the dairy supply chain, uh, which includes which includes the planning and scheduling, routing, traceability, sustainability, supply chain design. We have quality problems. We have supply chain performance measurement. Okay, so from this, we identified this area as supply chain performance of dairy supply chain. So the supply chain performance measurement is a very like a sort of area of the researchers for finding out or for evaluating the performance of any supply chain. Researchers The supply chain performance measurement system is studied for many different industries. The various areas of research in performance measurement of dairy supply chain are also being studied. If we study the different sub areas in supply chain performance measurement system, it comes to supply chain performance measurement system frameworks, supply chain performance measurement system models, the key performance indicators, which is the KPIs for SCPMS, that is supply chain performance measurement system. Then we have financial performance of supply chain, and then we have sustainability performance of supply chain. To discuss about the supply chain performance measurement system frameworks, the researchers have identified different supply chain performance measurement frameworks, which will be able to enable the effectiveness as well as measure the efficiency of the supply chain. So we have an author, Gunsekar Niti. He has also developed a supply chain performance measurement framework for four major processes: plan, source, make or assemble, and delivery. And this was applied to the strategic, tactical, and operational level of a general supply chain. Then we have something called as a lean supply chain, which is also gaining attention now. And this lean supply chain is basically the model. It focuses on elimination of waste across the various activities of the supply chain. Alfonso and Cabrita have also developed a conceptual lean supply chain framework in which they have focused on the financial and non-financial performance dimensions, and it has been applied to a SME. We also have Esvedo, Carvalho, and Cruzmado, who have introduced the concept of large, which implies lean, agile, resilient, and green. So this is also a concept which is being applied to the supply chain performance measurement framework. We also have authors Botany, Bigliardi, and Rinaldi, who have proposed a large PMS, which is comprising of 13 different lean indices for specifically a food supply chain. Then the dairy supply chain is also one of the complex supply chains because it is having the involvement of major external factors. So there is a need for integrating the outside partners also. So we have this Talukdar ETL. He's presented an integrated framework of LAS SRN, which is lean, agile, sustainable, resilient, and nutrition paradigm in the context of convergence innovation. We also have an author Khan as Asfar Nawar Khan and Hamza Gabriel, who have added different things or different part into it, like operational performance, economic performance, environmental performance to this existing large paradigm. Then we go to the supply chain performance measurement system models. So these models basically provide the framework and whatever are the metrics to assess the different aspects of the supply chain. There are different tools and methods which have been developed, which includes the balanced scorecard method. We have AHP analytical hierarchical process. We have management by objectives, data envelopment models, etc. Okay, these are all the techniques which are used for measuring the different factors. Then we have an author, Vatanbe ETL, who has identified customer satisfaction, production cost, and utilization as a key performance indicator using DEA. We have Adel Elbaz who has used the fuzzy set theory and the analytical hierarchy process to develop a model for evaluating the performance of the different departments of a manufacturing company. A supply chain involves a series of interrelated and interlinked processes. So if we intend to measure the performance of a supply chain, we need an integrated model, which is going to cover each and every link of the supply chain. So Samaran Yenke has proposed a conceptual framework of integrated supply chain in the dairy industry. We also have authors Prakong Vidya and Liangro Kapat, who have identified 54 different LARG measures for review to access the supply chain transparency for visibility, sustainability, integration, governance, and traceability. Then we go to the key performance indicators of supply chain. So key performance indicators are basically the quantitative metrics which help in assessing the performance of a supply chain. Now, obviously, these KPIs will be varying with the type of industry, whether it is a manufacturing industry, whether it is a food industry, whether it is a foundry. Okay, so it will vary with the type of industry, and it will also vary with what are the various processes those are followed in that type of industry. So in this, Salihin Habib has developed an integrated supply chain performance which considers the four different stakeholders, namely shareholders, customers, customers, people, as well as the nature. Then supplier evaluation is also one of the important aspects. Why? Because supplier is an integral part of the supply chain, whether it is a food supply chain, whether it is a manufacturing supply chain. So supplier evaluation remains an integral part, and the KPIs which are followed for supply chain are going to be different. And Ballon ETL has also identified different areas of a manufacturing organization, along with the key performance indicators in each area and guidelines on how to calculate the different KPIs. Then we go to financial performance measurement of the supply chain. Now, financial performance of an organization is one of the most important aspects for evaluating the long-term financial health of the company. Various research KPIs have been used by researchers for evaluating the financial performance. In order to measure this financial performance, it is first very important to understand the financial control systems which have been used in the organization. So Daniel, Adams, and Owens have discussed the impact of technological advancement like automation is stressed on the importance of sustainability. We have Unani and Familia who have discussed the application of probabilistic management model, and this was applied to the inventory, to the finance related to the effective inventory management. Then routine data collection and benchmarking are also important aspects of measuring, which helps in increasing the performance and thereby the profitability of the firm. We have the sustainability performance measurement of a supply chain. As we said, sustainability is the buzzword now, so people are coming up with different ways in order to become incorporate sustainable practices into their operations. Sustainable practices can help reduce cost, as well as thereby they can also help in improving the efficiency of the operations. We have Acme ETL, who has presented an environmental sustainability performance index for analyzing the carbon footprint of industrial supply chains using the industrial life cycle approach. We have the European Sustainability Report Standards, ESRS, which also provide a structured framework reporting on the ESG factors across the European Union. We have Bravo and Kenyato have.
Gentle
Yes,
reminder that you have crossed 9 minutes.
yes, ma'am. I'll go to the next part, ma'am. Yes. Okay, this is the area demand forecasting. So demand forecasting is a critical component of the supply chain management, which helps the organizations to predict the future demand, product demand, and align production, inventory, and distribution accordingly. It also enhances decision across the procurement, manufacturing, logistic, and customer service, which helps in reducing the costs and improving the responsiveness. Now, there are different machine learning algorithms which have been used for demand forecasting. So I have done a literature review for the different machine learning algorithms which have been used so far by researchers for demand forecasting, which includes support vectoring machines, random forest, gradient boosting, and then some hybrid models have also been used. Some ensemble models have also been used. Okay, so these different forecasting methods have been applied. Some of them have been applied to the food industry, and majority of them have been applied to the manufacturing industry and other service industries also. Okay, so these are the proposed innovations in dairy supply chain forecasting, which includes real-time IoT integration for dynamic forecasting, hybrid machine learning models for enhanced accuracy, federated learning for collaborative forecasting. We can have sustainability-oriented demand forecasting, adaptive forecasting for data scarce environments, decision support, dashboards for practitioners. Then we have multi-stakeholder and cross-functional integration, robust forecasting under uncertainty, explainable AI for enhanced adoption, and conceptual framework for integrated forecasting and performance measurement. These are the different challenges and innovations which have innovative solutions which have been identified across dairy sales. Now, the dairy scales can also be classified as small scale, medium scale, and large scale. So, considering what are the key challenges and what could be the potential solutions, these have been identified. For small scale, it is limited historical data, lack of access to advanced technology, high spoilage due to poor cold chain, low bargaining power with buyers. The potential solutions also given, you can have lightweight machine learning algorithms with small data sets, mobile-based IT platforms could be used. For medium scale and large scale, also we have identified certain key challenges.
Excuse me, ma'am. Go to the conclusion. Go
Okay,
to the
sir.
conclusion. No need to read the PPT.
Okay, sir. Okay, so in the conclusion, I would like to say that demand forecasting plays a very important role in improving the efficiency and resilience of the supply chains. This is a sector which specifically faces unique challenges because of the perishability nature of the products. Okay, there are conventional statistical methods which are useful, but often they fail to capture the complexity of the dynamics of this particular area. So machine learning, it offers while advanced capabilities by utilizing large data sets, and also it can help in identifying the hidden patterns, and it can also help in generating more accurate forecast. So it's if you try to adopt this, we can it will help in supporting better inventory control. It will help in minimizing the losses, and it can enhance the overall performance management also. So but there are certain issues like inconsistent data, high implementation costs, and limited interpretability of models. So these are there which require careful consideration. So in the future studies, we could emphasize hybrid forecasting models, which could be integrated with IoT data streams and sector-specific customization. So machine learning based forecasting provides a promising area, or it provides a promising pathway for both operational performance as well as long-term sustainability in the dairy supply chains. Thank you, sir.
Okay. I have two questions in my mind.
Yes, sir.
So your research combines the machine learning as well as the IoT. Okay. IoT is collecting data and machine learning is different algorithms you have studied, which is applied on that data collected by the IoT devices. So my
Yes, sir.
first question is that how does this machine learning algorithms, whatever you have studied, uh, whatever the ML learning, how it will be helpful for the waste management in this dairy, uh, whatever the DSC,
Dairy supply chain.
yeah, supply chain.
Sir, if we try to basically, sir, I'm thinking of I have this research area is focused on use of machine learning techniques for demand forecasting. So if you see, if you try to forecast the demand well in advance, then it will be helpful for us to minimize the losses, because demand this demand of the dairy industry changes with the season. It changes with the festivals, holidays, and even days of the week also. Now we have this factor weather, which is significantly impacting the demand for the milk products, whether it is mid-size and small dairy. So basically, the small dairies as mid-size dairies also, they also do not have the access to any of the data science technologies. So if we try to inculcate some of any of the machine learning model over there, if we had work on the past data and try to work on it, we could come up with certain patterns wherein it will be possible for us to predict the actual demand, and thereby it could help in minimizing the losses.
Okay, fine. What is the real time decision making in dairy supply chain of this IoT? What
Real
is the
time
main role in the real time decision making in the dairy supply chain?
I did not get your question. So real time in decision making with reference to is it with reference
Yeah.
to forecasting you're asking, sir?
Yes, yes, yes.
Uh,
What
Sir,
is the
it will
major role
be
of the IoT?
sir, it will help us to track the different things, like maybe the how much milk is got dispatched to a particular suppliers, how much has been gone to the distributors, how much amount is left, and all that. And also it will traceability will be there, sir, because of the IoT.
Okay, fine. Next.
Yes, thank you, ma'am.
Yes. Okay. Thank
Now,
you so much,
next,
sir.
I would call Madhura Chandrani to present her study on miniaturized triple band 2x2 MIMO antenna development for Wi-Fi, WLAN, and VMAX applications.
Yes. Is my PPT visible, ma'am?
Yes, ma'am. Please start.
Good morning, respected sir and ma'am. I am Madhura Chandrani, and today I will presenting my research work titled Miniature Triple Band 2x2 MIMO Antenna Development for Wi-Fi, Blend, and WiMAX applications. This work has been carried out under the guidance of Dr. Killul Pandya and Dr. Neri Pandya. I will begin with a brief introduction, followed by literature review, antenna design, measurement and setup, result, finally conclude with the future scope. In recent years, wireless communication systems have rapidly evolved, and there is a strong demand for antennas that are compact, efficient, capable of operating over multiple frequency bands. To support higher data rates and evolved reliability, modern devices widely use MIMO technology, which employs multiple antennas at the transmitter and receiver. Although MIMO improves throughputness, signal quality, and coverage, placing multiple antennas close together introduces major challenges known as mutual coupling, which degrades antenna performance. Therefore, designing a compact MIMO antenna with high resolution and stable multiband behavior remains key research problem. In this work, we will propose miniature 2 cross 2 MIMO antenna designed for Wi-Fi blend WiMAX applications with reduced couplings and consistent performance across the operating bands. Various researchers have worked on compact MIMO antenna design with improved isolation and multiband operation. Severe decoupling techniques such as defect ground structure, electromagnetic bandgap structure, and naturalized lines have been reported reduce mutual coupling. Slot-based radiation and parasitic elements and commonly used to achieve wideband and multiband performance. Why metasurfaced and based approachable to help suppress the surface waves. However, many existing design their increasing complexity, size, and cost. Hence, there is still a need for simple, compact, and efficient multi-band MIMO antenna, which motivated to purpose to design. In this slide shows the proposed antenna design and fabrication structure. In this slide, we can see this is the front view, this is the back view, and this is the isometric view of our antenna design. The antenna consists of two triangular radiation patches arranged in a compact 2 cross 2 MIMO configuration. Two conducting strip is placed between the patches to improve current distribution and reduce mutual coupling. The pentagon-shaped slot introduced in the partial ground plane, which enables multiband operations and enhance the isolations. The antenna is implemented on FR4 substrate, making the substrate low cost and low cost and for practical wireless communication. To validate the design, measurements were carried out to 5 cross 5 cross 5 meter anechoic chamber. A vector network analyzer was used to measure S parameters, including return loss isolation. The fabricated antenna prototype was placed on the non-reflecting stand inside the chamber to ensure accurate results. The measured results were then compared with the simulated results for validations. Now we will move to the results. Reflection coefficient, which can be said as S11. So in this figure shows the simulated and measured reflection coefficient curves. We can observe that both results match closely, which confirms this accuracy of the purpose design. The antenna operates effectively over multiple frequency bands. As 0.8 to 4.7 gigahertz, 5.6 to 6.85 gigahertz, 9.6 to 10.85 gigahertz, and 14.15 to 14.90 gigahertz. All this confirms proper impedance matching across all the targeted bands. Now we will move further for ECC and CCL slide. To evaluate the MIMO performance, envelope correlation coefficient and channel capacity loss were analyzed. The ECC value remains well below acceptable limits. And similarly, CCC value stays within the required threshold. This result confirms strong MIMO characteristics of the proposed antenna. Now we will move for gain in efficiency. The antenna exhibits stable gain across the operating bands. which is average gain is approximately 2.5 dB. Here we can see the dark brown color shows the computed value, which is across 2.5, and below that, the gain measured in orange color is closely to that dark brown line. The radiation efficiency reaches nearby 90%, indicating low losses despite the user of FR4 structure. Overall, the maintains consistent performance across the supported frequency band. From that, we can conclude that 2x2 antenna with multiband operation and high frequency has been successfully designed and validated. Both simulated and measured results shows good agreement across Wi-Fi blend and WiMAX band. The key performance parameters such as S11, ECC, CCL gain are in their desired limits. Hence, the proposed antenna demonstrates stable radiation behavior and reliable MIMO performance and suitable for modern wireless communication system. Here are the future scopes of this antenna. In future, the antenna design can be extended to support additional frequency bands for emerging wireless standards. Reconfigurable or tunable elements may be incorporated by dynamic frequency switching. Further enhancement in isolation technique and use of advanced substrate and metamaterials can also be explored. The antenna can be integrated into IoT portable, wearable wireless device or mobile phones. Here are the references. Thank you.
Okay. MIMO antenna you have chosen for this design. Okay.
Yes.
So, which parameters make this antenna suitable for whatever the communication protocol, that is Wi-Fi, wireless LAN, or WiMAX application? Can you tell me the which are the parameter that make the antenna suitable? Am I audible? Your
Yes,
voice
sir.
is breaking.
Madhura ma'am, can you please answer? Hello, Madhura ma'am, can you hear us?
I think so. Network connectivity issues there. Voice is breaking.
Madhura ma'am, can you please write your answer in the chat box if that is okay?
Antennas deflection coefficient as well when
All right, I'll move to the next presentation, sir.
Yes. Go to the next. How many remains?
Sir, I believe 3 to 4 are yet to present.
We are
Yes,
lagging.
there are 3 remaining, sir.
3 remaining. We are lagging. Okay.
Janvi ma'am, please start with the presentation on non-invasive blood type identification using a near-infrared sensor system.
Thank you, ma'am. Am I audible?
Yes, ma'am.
So let me share my screen. Ma'am, is my screen visible?
Yes, ma'am. Please do the presentation mode and start.
Sure. So good afternoon, everyone. This is Jahnavi, a student in VRSCC College. So my paper presentation is non-invasive blood type identification using an NIR sensor. So blood group identification is very important in medical emergencies, surgeries, and any blood transfusions. Currently, blood group detection is done by using painful blood draws and laboratory tests. These methods are painful, time consuming, and need medical staff for it. So our main aim is to do it in with no pain and do it in non-invasive way with good accuracy and quick response. So basically, in rural areas and all the emergency situations, some or in any accident cases, laboratory testing may not be available. So some patients are afraid of needles, especially like children and elderly people. So our main aim is to like create a non-invasive, quick and low-cost solution. So let me directly go to the block diagram so that I can explain it quick. So this is the complete block diagram where we take the NIR sensor and the output of the sensor is given to the Arduino along with the power supply, and through the USB cable, the laptop along with a machine learning model, like we use LSTM for durability and taking the on time more data for more calibration. And by the ML code, we detect the blood group. So an NIR sensor is used to capture the reflected light from the finger, and the Arduino is used to read the data that is coming from the sensor, and the laptop is interfaced with the LSTM model, and through the outputs are as shown here. So in this way, we get the output. So for training, we used by taking samples from across 1,000 to 2,000 patients from nearby diagnosis centers and all. Our kit looks like this, where a patient places their finger. We need ambient light and all, and the model is already trained. When the wavelength is absorbed at a particular point, based on that, the blood group is detected. Finally, I would like to conclude that the system is very useful in emergency, rural healthcare, and medical places. Where we used for large data sets and with good accuracy. This is portable, low cost, and safe for people to detect the blood type. That's it. Thank you.
There is no question. Please start next.
All right. Thank you, ma'am, for your presentation. Now, next, I would like to call K. Srivalli to present her study on smart, non-invasive bilirubin detection system using near-infrared sensor.
Is my screen visible, ma'am?
Yes, ma'am.
Good afternoon, everyone. I am Srivalli. Today I am presenting my paper titled Smart Non-Invasive Bilirubin Detection System using Near-Infrared Sensor. Coming to the introduction, bilirubin testing is important for diagnosing jaundice and liver disorders. Conventional methods require blood sampling, which is painful and increases infection risk. These tests need laboratory facilities and time, and delay in detection may cause serious complications. Therefore, a non-invasive and real-time monitoring solution is required. Previous research shows the near-infrared spectroscopy can be used for bilirubin estimation. Optical sensor-based methods were proposed, but accuracy was affected by lighting and skin tone. Studies also proved that LSTM models perform well for biomedical signal classification. However, a complete non-invasive real-time system is still required. The proposed system estimates bilirubin levels non-invasively using near-infrared sensor. Arduino Uno acquires the data and send it to a laptop. A Python-based long short-term memory model classified the bilirubin levels as normal, moderate, and critical. The system is low cost, portable, and suitable for real-time monitoring. The user places a finger on the NIR sensor. The sensor emits an infrared light and captures the reflected signal. Arduino transfers the data to the laptop through USB. The laptop preprocesses the data and the LSTM model predicts bilirubin level. And coming to the hardware components, Arduino Uno is used for data acquisition and communication due to its low cost and ease of programming. It acts as an interface between the NIR sensor and the processing system. NIR sensor details. AS7263 NIR sensor is a 6-channel digital NIR spectrometer operating in the range of 600 to 870 nanometers. It captures spectral variations related to the bilirubin concentration and supports I2C and UART communication. Hence, it is suitable for non-invasive biomedical applications. Coming to the results, the system successfully predicts the bilirubin levels in real time, and overall accuracy achieved is 93.3% under controlled conditions. The testing time is faster than invasive methods, making it suitable for rural and telemedicine applications. Compared to the invasive blood test, the proposed system is painless and non-invasive. It provides faster results and is portable, although laboratory methods show slightly higher accuracy. Coming to the conclusion, a smart non-invasive bilirubin detection system has been developed successfully. Integration of NIR sensor with LSTM improves prediction accuracy. The system is low cost, portable, and suitable for hospitals, rural clinics, and home care environments. Future work includes expanding the dataset, cloud and IoT integration, and clinical validations to improve the accuracy. Thank you for your time and attention.
Okay, can you tell me how can this system benefit remote or resource constraint or limited healthcare settings if there is a limitations? How your system will be helping?
It is a non-invasive, painless, and faster and does not require laboratory infrastructure, which is making it suitable for real-time and remote sensing.
Okay, what advantage does the LSTM model provides for this application? You mentioned that LSTM model in your presentation.
LSTM handles the sequential and temporal data effectively, which improves the classification accuracy of spectral signals compared to the traditional models.
Okay, that's it from my end.
Thank you, sir.
Yes, thank you, ma'am. Now, lastly, I would ask Soumitra Mehti to present his study on Towards Intelligent Edge Security, a survey of artificial intelligence-based edge intrusion detection systems.
Oh, thank you, ma'am. Let me share my screen. Well, start.
Yes, sir.
Okay. Good afternoon, respected chairperson and fellow researcher. I am Soumitra Maiti from the Department of Computer Science and Engineering in MAPOUT. Today, I am pleased to present our paper in your esteemed conference 10 ICTCS 2025. Next, my brief outline. The structure of my presentation. I will start with an introduction, then explain layered architecture of edge computing. After that, I will discuss need for edge intrusion system, then ML, DL, and HL approaches. Then so I conclude my presentation. Introduction. The rapid growth of IoT has resulted in massive heterogeneous network traffic, especially at the edge of the network. This is significantly increases exposure to cyber threats such as DOS, DDoS malware, and spoofing attacks. Traditional intrusion detection systems were designed mainly for centralized network and cloud environment. As a result, they suffer from the high latency, bandwidth overhead, and privacy issue and poor scalability. When deployed in edge environment, edge computing enable real-time processing close to IoT devices, but edge nodes are typically resource constrained, which introduce new security challenges. To overcome this limitation, AI-driven edge intrusion detection system using machine learning, deep learning, and hybrid learning have gained significant attention. This survey systematically reviews their architecture, dataset, strength, limitation, and identifies open research challenges. Next, illustrate the three layer of architecture of the edge computing. In the edge computing, if we know that first layer is cloud computing layer, then fog layer, then edge layer. In the cloud layer, large scale of storage and high performance computation, it is mainly used for deep analysis, long-term training, model training, and global threat intelligence, but it not suitable for real-time detection due to latency and privacy concerns. In the fog layer act as an intermediate layer consisting the gateway, router, and micro data center. It performs data aggregation, filtering, and localized analytics, reducing latency and bandwidth usage between the edge and cloud. Finally, the main layer is edge layer, including IoT devices such as sensors, smart cameras, vehicle, and wearables. This layer enable low latency responses and initial intrusion detection, but it is highly resource constrained, making security design particularly very challenging. Next, what is fog device, edge device and its security challenges? Edge device operate mainly close to data source and critical for a real-time decision making. However, these devices have limited CPU, limited memory, and limited storage, and also limited power, which prevent from them running heavy security mechanism. Edge environment face a wide range of attacks, including DDoS, malware, data injection, spoofing, and zero-day threats. Major challenges include handling high volume and heterogeneous traffic, ensuring data privacy, detecting novel and evolving attacks, and dealing with imbalanced dataset and lack of real-world validation. These issues clearly highlighted the need for the lightweight, adaptive, and intelligent edge intrusion detection, especially designed for the IoT edge environment. Next, we use three learning approach. One of them is machine learning approach. In this slide, uh, summarize various machine learning based EIDS approaches, techniques such as random forest, decision tree, gradient boosting, and isolation forest have been widely adopted due to their low computational overhead and fast interference. Several studies report high detection accuracy and low false positive rates, making uh, machine learning suitable for edge development. However, most ML-based systems rely heavily on feature engineering and struggle with complex attack patterns and often show limited generalization across datasets. Despite these limitations, ML models remain attractive for resource-constrained uh, edge devices. Next is deep learning approaches. In deep learning approaches, we choose some best and recent published paper and approaches leverages model such as CNN, LSTM, BiLSTM, fast RNN, and fast GRNN to capture temporal and spatial patterns in the network traffic. These models significantly improve detection accuracy, especially for complex and evolving attacks, and reduce false alarm. Lightweight DL model like fast RNN and fast GRNN are particularly promising for edge devices due to their small model size and low computational cost. However, deep learning models often require large level of dataset, having high training cost, and may struggle with rare unseen attacks, especially in real-time scenarios. Next, hybrid learning. In hybrid learning combines the strength of machine learning and deep learning. Example include autoencoder with deep MLP, feature selection based ML based ensemble, and light GBM combined with MobileNet version 2. These approaches achieve may high accuracy, often above 99%, while reducing false positive and computational load. Hybrid systems are particularly effective for edge environment, but they introduce increased system complexity, require careful tuning, and still lack of robust validation against zero-day attack. We use some datasets like traditional datasets such as NSL KDD, UNSW NV15 are widely used due to benchmarking and convenience, but they suffer from the outdated attack profiles and limited IoT relevance. So more recent use like bot IoT, CIC IDS 2017, CIC IoT 2023 better represent IoT traffic but suffer from the severe class imbalance and complex preprocessing requirement. Overall, there is a strong need for modern drivers and a realistic dataset such reflect a real-world edge environment. We got some observation and findings from our paper. We observed that clear shift from the rule-based intrusion detection system to ML and DL and hybrid approach-based intrusion detection system. Hybrid model offered the best balance between accuracy and efficiency and scalability. It's a lightweight if we use is a lightweight deep learning and stage detection approaches are promising for low power edge devices. So that's why however major challenges are conclude in this factor. So poor limited zero-day attack, lack of real world deployment, and minimal focus on explainability. Future scope. Based on our identified gap, we outlined several future research in this direction. These include adaptation to novel and evolving threats, privacy preserving, collaboration in intrusion detection system, and real world deployment and validation. Additional focus area are lightweight, energy efficient, and handling data imbalance, rare attack, and hybrid ensemble optimization. So to conclude this survey paper highlights the transition from the traditional intrusion detection system to AI-based edge intrusion detection system for modern IoT and edge environment. ML and DL techniques have significantly lower than the hybrid learning approaches. Hybrid learning approaches in detection accuracy is high, it's a robustness, but challenges is related to latency, resource constant, data equality. But EIDS solution must be lightweight, adaptive, and privacy preserving and explainable.
Okay, nice presentation, Soumitra.
Thank you, sir.
How can IEDS handle the zero-day or unseen attack?
Yes, sir. Yes, sir.
How can your research, whatever the IEDS, handles the zero-day or unseen attack?
Because of deep learning model are adaptive for the automatic features selection model.
Okay. Which learning approach you have mentioned that ML, DL, or hybrid most effective for EIDS?
Hybrid learning, because here we use combined feature of the machine learning and deep learning.
Okay, thank you from my end.
Thank you, sir.
Yes, thank you, sir, for your presentation. And now with this, we are done with all the presentations and we'll move to the closing remarks. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days, and the publication will be live within 7 to 8 months. I also thank our session chair, Dr. Ganesh Pise, for chairing the session. I am sharing a token of appreciation on behalf of Team ICTCS and Global Knowledge Research Foundation and partners. Thank you, Dr. Ganesh, for your valuable presence, and I request you to share any concluding remark.
Thank you, Patel ma'am. So, first of all, I would like to thank our ICTCS 2025, all the team, Amit sir, whatever the authors they have presented the paper in this track, digital mode. All the papers are presented in a relevant, as well as all the papers are well organized, well studied, confident presentation was there. I understand the clear motivation from the authors about their research and the sound technical contents. The analysis of this future direction and the value added to this field, all I found in a well organized technical sound conference paper presentation. So I request the conference head, whatever the papers are presented in this digital platform, as per your terms and condition, you supposed to accept all this paper for your next process. Once again, I thank you all the organizing team and ICTC 2025. Thank you, Patel ma'am.
Thank you so much, sir. And now with this, we conclude this session. I would request everyone to please turn on your cameras for a quick snapshot of this conference. All right. Thank you, everyone. Have a great day ahead and take care. Thank you.